Well, hi, everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 31st, 2013. So joining me this week, we've got Sandy Springman from Puerto Rico, who we will always ask her to point out the window so we can see the Arecibo Observatory. Check it out. That's awesome. We've got David Dickinson from Florida.
Hey.
How's it going? We got Emily Lochtawalla from the Planetary Society. Yay! Emily's back. Dr. Ian O'Neill from Discovery Space. And we've got Dr. Matthew Francis. And our silent partner is Dr. Nicole Gallucci, who is with us in spirit, but not here in audio. So there she is. You can't hide behind the Weekly Space Hangout. You just have to, from here on out, your part of this episode will just be hand gestures.
Actually, what I think she should chat everything, and then one of us should speak for her, so that it. Yeah.
Right. Right. Exactly. Yeah.
I'll be glad to do the dramatic reading.
There we go.
So this week we got a ton of space news. So we're going to probably go at light speed. So we're going to be talking about this cool new pass from an asteroid. We've got more updates on Curiosity and Opportunity, the Kickstarter campaign for the Arcid Space Telescope, the end of dark matter annihilation, maybe. How you're going to be able to see the International Space Station at night, upcoming mission to launch to the Chinese space station, rats on Mars, or not, using pulsars as galactic GPS. So, wow, what do I want to start? I want to start with the asteroid first, because that was really super exciting. So, Sandy, if people remember last week, you actually predicted that that not only would have this asteroid pass by, but that it might even have a moon. And how did you know this?
Well, I had about a 15% chance of it having a moon. About 15% of the asteroids that come by the sun that are near-Earth asteroids actually have moons. And about 20% of the asteroids that come by Earth are actually contact binaries, so they look like two potatoes stuck together, perhaps like that. So, there was some chance that this would have a moon, and it was large enough, and by golly, it has a moon. And it's interesting that in the radar images, everyone's saying, gosh, that moon looks so much brighter than it does, but it also looks a lot smaller. But people are saying that this moon is about the quarter the size of the asteroid. And actually, that's just an artifact of how radar images work, that it just looks brighter. It's actually not like a 3D, it's not an image like you take with your camera. It has to do with how far away the object is and how fast it's moving. And since the moon is moving very slow, it appears very bright.
So why don't we ask that question again, and this time you can explain how you went outside with your headphones, plugged into the Arecibo Observatory, and just listened to the sound of the asteroid, and you could hear a moon in there.
Well,
No?
we haven't yet observed it here at Arecibo. It's on our schedule for next week. So right now, our friends at Goldstone, run by JPL out in California, have been looking at it. But the Goldstone telescope can point. It can point up. It can point to the sides. They've been looking very low in the sky as this asteroid rises. Whereas Arecibo, we have this giant fixed dish in the backyard. It's 1,000 feet across, but it can't move. So we can only look 20 degrees up from the zenith, from the top of the sky. So we'll be looking at it next week when this asteroid gets higher. And as much fun as it would be to be like Jodie Foster with a giant set of headphones listening to the sounds of the universe, our radio waves are actually converted into signals and fiber optics pretty quickly, and then they come down into our control room where we sling around a bunch of BNC cables, and eventually they come out into a computer that's from the mid-90s. And then we get the
destroying the illusion for me.
That's how science gets done, and then eventually
right.
This all turns into lovely images like the ones you've seen. I think Emily actually has an animation queued up on her screen right now of asteroid QE2 and its moon rotating. I don't know how we move over to that, but...
Oh, well, Nicole, I'm sure, will be doing it. Yeah.
Yes, Nicole is on it. She gave me the thumbs up.
Yeah, now, because she doesn't have to talk, she can just focus on moving the camera around. Oh, I mean, you can imagine what she's saying. She doesn't even need to talk. We can just see her gestures and her laughter. It's perfect. So play this out for us. What's going to happen over the next few days? Because we're still not at the closest point, right?
I think the closest point is happening this weekend. It's going to start moving a little further away, but this thing is so large and so close that Arecibo is going to get a lot of very good signal to noise on it. We're going to see really exciting details. So you can start seeing in this animation. You can see craters, you can see features, you can see boulders, and when the asteroid comes to Arecibo and we have a much more powerful transmitter here, we'll be able to see the craters in greater detail. We probably won't be able to get too many details on the moon, but we're going to be seeing a lot more about this asteroid. And with the moon, if you remember Kepler's laws of motion, if you know the orbit of something around an asteroid, you can actually figure out the mass of the asteroid from the orbit of the moon. So this moon is really exciting. It lets us do a lot of really cool science here.
Sandy, have they published an orbital period for that yet, that moon?
I have not yet seen an orbital period. The modeling of these things is actually, it's really involved. You take all the radar images you get, you take light curves you get from optical telescopes, maybe from amateur astronomers. If there's any amateurs out there with a clear view of QE2, please get some light curve. We'd love to have it.
I've seen some animations already that people have been doing. So
excellent. Yes, please keep that up. And then we pour it all into this model with the exciting name of SHAPE, and you can actually get a shape model of the asteroid and its little moon, and this will tell us how big it is, and we already had an idea what it's made of. So this can help us study other asteroids.
We're just under 2 hours from the closest pass.
Really?
It's at 4:59 p.m. Eastern Daylight Time. So about an hour after we end.
We should just wait then.
Yeah. Of course, it's not passing. It's passing roughly 15 lunar distances.
Million.
So yeah.
It's pretty far away. I'm not going to worry. And if you're worried, please don't.
But it's a really a relatively close pass with a large asteroid that we're going to get a lot of good data on. So I think this is
it's a really exciting opportunity for not only the radar folks, but also for amateurs to get some data. And also with radar, it's, for most times when you want to take images of an asteroid, you have to send a spacecraft up there, and that costs millions, if not billions of dollars. And here you can get something really for the price of diesel and a couple people's salaries to look at images of an asteroid. I'm not saying we should keep funding space missions because they produce way more than we can do in a couple hours here, but this really shows that you can do a lot of amazing things with radar.
That's great. Well, hopefully we'll be able to provide some of those pictures next week, so maybe if you'll join us again, that would be great. So I just want to remind people that they can actually comment and give us feedback and talk to us as we're recording the show. So there's a few places you can do that. If you're watching this on Google Plus on the event page, you can post a comment there. If you're watching this on YouTube, you can make a comment there. If you're watching on Twitter, just use the hashtag Space Hangout. And I guess if you're watching this in Nicole's stream, you can make a comment there. And hopefully we'll be able to kind of gather them all together. But if it looks like nobody is answering your questions or not, noticing your comments, I recommend switching over to YouTube. So just click on Watch on YouTube, wherever you're seeing this video, and then you can make your comments there. I'm going to move to Emily Lochtawala, who we haven't seen in a while, so it's great to have you back, talking about updates on Curiosity and Opportunity. So let me think. It's been, a few months, so I think the rest of the show is yours. So many updates.
Well, it's actually been kind of a low time on Mars because throughout the entire month of April, both of the spacecraft were hardly doing anything because Mars is very close to the sun in Earth's sky. And that doesn't affect anything for anybody sitting on Mars, but it does make it very hard for us to communicate with spacecraft. So they don't want to tell the spacecraft to do anything that could possibly risk anything, which basically means they do very little. But finally, after the end of April, they finally got moving, and really, it's Opportunity that's really been doing the moving. I have a map here that I'm going to share, and what you can see is Opportunity's route map. Way back in 2667, 2681, it approached this little chunk of Endeavour Crater Rim called Cape York, and it has been there for 2 years now, actually exploring Cape York. It spent the winter up here at the north end of Cape York, spent a whole lot of last year and much of this year exploring this one area called Matiavik Hill, where it's seen some of the oldest rocks that Opportunity has ever explored, some ancient clay minerals, the likes of which Curiosity was sent to Mars to explore. But finally, the seasons are changing. They need to get to their new wintering spot for the next Martian winter. The winter solstice comes, I think, next February. And so they have started booking. So you can see little red dots here. Each one of those is a nearly 100-meter drive to the south. And now I'm going to quit sharing that screen and bring up a different screen that shows you the view of Sutherland Point. And I just think it is the most amazingly cool thing. Even now, We're 3,300 sols into the mission. I think it's absolutely amazing that we can follow along with what these rovers are doing. These images came down just yesterday, and this kind of rocky area is this place called Sutherland Point. Opportunity is going to be exploring that a little bit, spend maybe a couple of weeks there, but then she has to book on south to this spot, which is called Solander Point, or actually, that may be Nobby Hill, and this may be Solander Point down there, which is where she's going to spend the next winter with her solar panels tilted toward the sun. The stuff she's found is pretty cool. She's found these ancient clay minerals, like I said. But, of course, Opportunity is such an old lady now. Most of her instruments aren't working anymore. And it's back on the other side of Mars where Curiosity is, where we actually have a spacecraft whose instruments are capable of telling us a lot more about these clay minerals. And since conjunction, Curiosity has driven about exactly a meter, which is to say not very far, just a little bit to the right of where she was before, and drilled her second hole. And now she's parked there for a while. She's analyzing the stuff that she dug out of that second hole. But in the meantime, while we're waiting for these analyses to happen, they published their first 2 peer-reviewed papers in Science magazine this week. And the big one, the research article, the first author is a lady named Becky Williams. She and I did an undergrad program in spacecraft image data processing at the same time, way back a long, long time ago together. So I'm very happy to see her have the first authorship of the first peer-reviewed paper that came out of Curiosity. And it's about these fluvial conglomerates that Curiosity found on Mars. So what does fluvial mean? Fluvial means that it formed in a river. Conglomerate means that it's a rock that's made up of chunks, sometimes big chunks of other rocks. And again, I have a picture of that. Let me share it. When I first saw this image, I thought that it looked like the kind of sidewalks that we have here in LA, where you have what's the ficus trees. LA grows gigantic ficus trees, and they do terrible things to sidewalks. Their roots pop up sidewalks. It really looks like broken concrete. And if you zoom in, concrete is an aggregate made up of chunks of rock stuck together in a matrix, and that's exactly what we're looking at here. And you can see the little chunks of rock that erode out. You can see that they have these rounded shapes on them. And that tells you something really important. If you've got biggest chunks of rock that are rounded, there's only one way you can make those, and that's by tumbling them in a river. And so this is really the most direct evidence of running, flowing water on Mars that anybody has ever seen. And it really is the first big discovery made by the Curiosity mission. The discovery was, of course, announced quite a while ago when Curiosity first drove past these, but this is an actual peer-reviewed publication where other scientists said, yes, we agree, those are fluvial conglomerates from Mars. So it's official. Curiosity has landed in a spot where there was running, flowing, swirling, pooling liquid water doing fun stuff to sediments and rocks, and maybe could have been an environment that ancient life could have once existed in. Not that Curiosity can find that, which I think is probably a cue for Ian's talk a little bit later.
Well, I was just going to say, and this leads perfectly into Ian's announcement of rats on Mars.
Yeah, forget your beaches. We found animals on Mars. No, there's a conspiracy site that kind of went crazy with an image from the Mastcam camera from Curiosity. I think it was like Sol 52. So it was very early on in the mission last year. And it took a lovely image of the panorama around Curiosity. Of course, conspiracy theorists, they've got kind of a overactive imagination, but you got to hand it to them on this one. It is kind of cool. They were analyzing some rocks, and a few meters away from the rover is what looks like a rat, to be honest. And once you see it, you can't unsee it. That's definitely a rat. You look at it and you analyze it, and I thought it was actually doctored at first, so I double-checked and actually looked at the original image from Curiosity, and there it is. It actually looks like, it probably looks more like a gopher. It's being banded around as a rat, but I think it's actually a Mars gopher. Kind of cute. But actually, this is a very well-known psychological phenomenon with our brains that tries to find familiar shapes in apparently random objects. So in this case, it's a rock, sadly, It just has a face that looks a little bit like a rodent. And to be honest, this little rodent was a little bit scared. I would be a bit scared as well if I saw this big alien robot with a big laser pointing at me. So there's reason for it to be cowering behind the rocks. But sadly, it's not a rodent. It's actually just a rock. And that's really my contribution.
So, Ian, I had a little fun with this week. I challenged my readers to look in a curiosity panorama for other such animals. They found like this platypus here and this lizard creature.
That's a good one.
My favorite has to be the fortune cookie down here, because you got to know what's the fortune. Curiosity needs to drive over there clearly with the wheel and knock that rock in two and tell us what the fortune is. I also like this whale head a great deal, as well as the despondent rock and the jovial rock.
Yeah, it's really funny because this happens a lot, and of course with any random shapes, and of course all the rovers have beamed back images of random shapes from the rocky Mars surface, and unfortunately it is just rocks, but if you really do pay attention, as you just said, you can find really weird shapes, familiar shapes in apparently random scenes. I did an analysis, a very comprehensive scientific analysis back in 2009. It was of opportunities analysis around, I think it was, which crater was that? I forget. But was it Victoria Crater? I forget, in 2009, opportunities was looking at. But it's all this rocky outcrop, and I'll try and share my screen without it breaking.
Well, while you're searching for that, I know there was a recent, I think it was a German group that had come up with an algorithm to search for faces in Google Earth imagery.
Yeah.
And they had just like turned up dozens of faces that people had never, I guess, sort of thought they looked like faces before. And, you can see, like, you can even have computers doing this. You should have computers looking for all kinds of faces and features on Mars.
And it's very easy. It's almost like, do you remember that back in the early 90s when you had those magic images where you went a little bit fuzzy-eyed, a little bit cross-eyed, and you see these three-dimensional images hop out of these random assortments of colors?
Yeah.
I think they're called magic eye paintings. It's the same thing with these images from Mars, and like this one I've just screen shared. This was actually in response to another conspiracy website who thought they saw almost like a chiseled image of a pharaoh in the side of a rocky outcrop, and I thought, well, let's just run an experiment of what can we see here. And so I had a look, and you can see Jabba the Hutt's face in there, you can see a gorilla's face, you can see the alien from Predator's face, you can see a skull there. It's just seemingly endless, the number of shapes that pop out of you if you just go a little bit fuzzy-eyed and use a little bit of imagination, you'll be able to see it. And that's pretty much what this is. This is just a psychological phenomenon that tricks your brain into thinking it's seeing something familiar when actually it's not. It's just rocks. But it makes for fun writing. Let's put it that way.
Like faces in a grilled cheese sandwich.
Exactly. So it's the same. It's exactly the same thing.
Yeah.
I'm showing
right.
my absolute favorite one of all time, which is the Sasquatch.
Yeah.
The mini Bigfoot.
Oh, yeah.
Yeah. And one thing that was fun to do in debunking this one is because it's the rover, you can actually go back in and see all of the times that Spirit took a picture of this one. And in 3 days, the little guy never moved. And also he was tiny. He was just like a few inches tall. So the conspiracy theorists weren't convinced that it wasn't Bigfoot, but I think most of the people who have half a brain cell were convinced that it wasn't actually a Sasquatch on Mars.
All right, we're going to move on. Now, David, it's prime ISS season.
Yes, it is, as we're entering toward the June solstice, the summer solstice up here and the winter solstice down under. The ISS is entering into a period of illumination where the sun never really sets on it. Starting on June 3rd and running through June 8th, the ISS is going to be in permanent illumination, and that means for higher latitudes between 40 to 60 north or south, you'll be able to see the ISS on multiple passes. In the UK, they can see it for sometimes even 5 times in one night. It'll pass over every 90 minutes. They'll see it pass over from those high latitudes. Here down in Florida, we'll probably see it. Maybe we'll have to be satisfied with once or twice a week.
There's a time lapse on the NASA site, and I'm sorry I don't have it handy, but where you see the sun just go down from the perspective of the space station, and then just go down for a second, and then come back up over the Earth's horizon, and so it's just going to be going through that.
It's nearly in that phase right now. If you look at its orbital path right now, the sun only sets on it for a moment or two, and they actually have to orient the solar panels, the station managers orient the solar panels to provide some artificial shade just to kind of disperse heat. And that goes back to repairing those ammonia pumps. That's why it was so crucial, because they need that cooling power as they enter into this phase right now of permanent illumination that's going to go on.
So if people want to be able to see the space station, how do you recommend they go about it?
Oh, there are dozens and dozens of different ways. Matter of fact, whenever I write about the ways I do it, I usually get comments where people tell me about apps I've never heard of before. I use Heavens Above. It's strange to think I've been using Heavens Above since '99. It's been around for a long time. It's a really good site for prediction and tracking satellites. Another one I use that's a little more technical for satellite trackers is a program called Orbitron. What's cool with Orbitron is you can actually run that with a laptop out in the field, and you can put your own TLE coordinates for satellites in and track them that way. It's a little more technical. The simplest one, I think, is Space Weather's Tracker, at least for the US and Canada, because all you got to do is enter in a zip code, and it tells you tells you the direction to look and the altitude it's going to pass. All you got to do is look at the right time, and you see it.
I like Spot the Station, which is actually from NASA. Same thing. You put in your zip code, postal code, and then it'll give you a reminder before it's going to happen. And the other one that's great is Twist, TWISST on Twitter, and they'll send you a tweet. They figure out your location, and then they send you a tweet just a little before the station's actually due to pass overhead. So that's a really good one.
That's a no-brainer. It's like you're on Twitter all the time, and suddenly it says, "Hey, the space station's above you." And you just go outside.
Somebody a year or two ago designed a lamp that actually lit up whenever the International Space Station was passing over. I remember seeing that a few years ago, that it actually would light up when it was overhead. So
it's pretty great to be. It's almost like a superpower. You can say, "Oh, hey, check this out. There goes the space station." If you time it right, you can show people. Grab the neighbor when you're at work or something.
A lot of people ask me too, it's like, well, how do you know that's the International Space Station? I say, well, compare it to a plane. What you're seeing is that's actually up there overhead. You're seeing it at dawn or dusk with the sunlight reflecting off it. So it's not flashing like a plane light will be flashing. Satellites will flash if they flare, but you're seeing the reflected sunlight. It's a different sort of flash when you see it, not a bright, quick flash. And the ISS will kind of flare when the solar panels turn. I can see a little bit of detail on it with binoculars when I look at it. It looks like a little miniature Star Wars TIE fighter in binoculars, depending how it's oriented. Sometimes it's edge on, and then sometimes it's flat on where you actually see the panels facing toward you, and it looks just like a little glowing TIE fighter in binoculars.
That's really great. Yeah, that thinking to use your binoculars is something that I don't think a lot of people realize, but even just with standard, 8 by 15 binoculars, 8 by 35 binoculars, you should be able to see something.
It's about the angular size of Saturn with its rings. So if you can see the disk of Saturn in the little stubby rings with your binoculars, and you'll be able to see a little bit of detail, depending and it's got to be overhead too, because it's actually a variation from about 250 miles to about 1,000 miles when you're seeing it on the horizon coming up. So it's a lot closer when it's overhead versus when it's on the horizon.
Awesome. Okay, so Dr. Matthew Francis, you've got sort of the end of a theory about dark matter annihilation.
It's not the end of a theory, but it's one of those. You might recall last year there was some buzz over whether there was the Fermi Gamma Ray Space Telescope monitors the sky for interesting gamma ray events, high energy events, and there was an announcement last year that there was an excess of gamma ray photons coming from near the galactic center. And well, that's interesting because if dark matter, the stuff that makes up 80% of the mass of the universe, is colliding and annihilating and making gamma rays, that's where you'd expect to see that kind of signal. So it's kind of an interesting idea. But the thing was that, of course, what you're seeing is gamma rays. You're not seeing dark matter directly. So the question is, how do we know what we're seeing? And so the Fermi team went back and looked at all the data again, close to 4 years worth of data. I don't envy anybody that kind of analysis. And what they did is they looked at all the possibilities they could think of. Well, okay, I shouldn't say all of them. They looked at a lot of the possibilities they could think of, because there's way too many possibilities. I went to a conference a few weeks ago, and man, I swear all the talks about all the different dark matter models that are out there, I couldn't keep track of all of them. But you're basically saying, okay, if dark matter is distributed this way, where would you expect to see the gamma ray signal? And what they found is, when they did this full analysis, they found that, yes, there are still a few extra gamma rays coming from the center of the galaxy, but it's like just barely a bump over noise. It could be over all the other sources of gamma rays in the galaxy. So it doesn't look promising, frankly. And by the way, this is analyzing exactly the same data that was used to make the announcement last year. So it's not the new data. As Fermi continues to operate, it's going to keep collecting more and more. And so we'll settle this one way or the other probably pretty soon, but it's really not looking good. However, one thing to be very clear about is that this doesn't say anything about whether there's dark matter near the galactic center. It doesn't say, or even whether it's annihilating. Because this is something I didn't know until I started looking into it for the story I wrote. But it turns out, dark matter is weird. It should be called invisible matter because light shines right through it. So when dark matter annihilates, it doesn't annihilate directly into gamma rays. Like if you take an electron and an anti-electron, a positron, and run them into each other, they turn into gamma rays. If you run two dark matter particles into each other, then they may or may not make gamma rays depending on what the dark matter is actually made of. And how often they make gamma rays, again, depends on what kind of model you're talking about. So maybe 1 in 10 dark matter collisions will make a gamma ray. Maybe 1 in 10,000 collisions will make a gamma ray. And so that means we don't know. I mean, there could be gamma ray, there could be a dark matter annihilation party going on, and we wouldn't see it because we're not getting very many gamma rays from it. And dark matter annihilation party, anybody can use that as an album title if they want.
Is that a band? Yeah.
So
Dark
anyway,
matter annihilation. That's a band.
It seems kind of disappointing to say, okay, we have to say now this probably isn't dark matter. There might be dark matter still hiding in the signal somewhere, but we haven't found it yet.
Then what is causing this excess of gamma radiation?
It's not sure yet. And the thing that's weird, this is something that's weird, is you can actually get gamma rays from the atmosphere. When a cosmic ray, a particle from deep space, hits the atmosphere, it can spit out gamma rays. And what they found is they found an excess of gamma rays at exactly the same energy coming from Earth's atmosphere. And they have no idea why that is, because there shouldn't be an excess from that. So that doesn't explain the entire bump they're getting from the galactic center, but it's use a technical term, it is weird.
So the Earth is like hulking out.
Or something, who knows?
Yeah.
I mean, we'll hear more about this, is the upshot of it.
All right, so I'm going to move back to Emily. Nicole, you've got compelling evidence of the discovery of aliens. You want to present it now? No, we'll have to wait. All right. So Emily, you, and I know the Planetary Society has been involved in this, which is this really cool Arcid Space Telescope, which has run a Kickstarter campaign to massive success.
That's right. The Planetary Society is definitely a supporter. I don't want to take any credit for this project. It's all Planetary Resources and Chris Lewicki.
It's all your idea.
But anyway, so Planetary Resources is one of 2 companies that are trying to get started with deep space mining, the other one being Deep Space Industries. And I saw them both give, both Chris Lewicki and Rick Tumlinson give presentations at the Space Fest conference in Tucson this weekend. And Chris cracked a funny joke. He said, when you're just one deep space mining company, then you're crazy. But if you've got 2, you're an industry. And they've actually been talking to people on Capitol Hill about things that will benefit government policy that will benefit deep space mining. But
as soon as they regulate it, then you're serious.
It's an industry.
Yeah.
Right. But Chris Lewicki and Planetary Resources, they've done a really nice job of laying out kind of interim steps that will get them practical steps that are going to eventually get them to being able to mine asteroids. And the first thing that they have to do is to discover nearby asteroids that are close enough to send their little teeny spacecraft to. The first step to doing that is to develop their own spacecraft capability that can find asteroids. And that's where ARCID comes in. ARCID is a little spacecraft. It's got a small telescope on it, an 8-inch telescope, 20 centimeter. This is not the kind of telescope they will be using to discover the kinds of NEOs that they want to head to. They need a bigger telescope for that. But it's a test of all of the avionics and everything else that they're going to need in order to make a spacecraft that will work to discover NEOs. So this is a baby step, but it's a step in the right direction. To reduce their risk, they're going to build several of these at once, probably 3 or 4. And launch them all, and if one fails, who cares? We got 3 extra. And one of the things that they are doing with one of their spacecraft is to crowdfund part of it. So they're using Kickstarter to raise $1 million. The $1 million is not actually to build the spacecraft. It takes closer to $4 million to build a spacecraft. It's to fund the launch, the operations, the development of their software, as well as a whole bunch of education programs that they're going to do with this particular telescope. It's a space telescope that members of the public can apply for time for and actually use to point it at whatever they want. It's a really cool idea. It's kind of like these things like SLU, and you probably, Fraser, can you mention some of these other like public available telescopes? I don't know them as well.
Oh, this iTelescope?
Right, stuff like that.
Yeah.
Except it's in space.
Except in space, yeah.
And it seems to have really hit a chord with the public because their goal is $1 million. I think people are like, well, they should be able to raise a decent amount of money, but $1 million's an awfully big number. It's been a day and they already have $500,000.
Yeah. Right now they have 30 days to go and they're at 558,000. Yeah,
so it's pretty amazing. One of the neat little tricks they did to get people to come in at a really small dollar level, and this is where I contributed, is that the spacecraft carries a teeny little LCD screen and an even smaller webcam that they can use to shoot what they call space selfies. So for $25, you can upload a picture, any picture you want, and you can get a photo of this picture on the spacecraft with Earth in the background, it's silly, but it's a great way to get people to pay $25. At higher levels, you can actually do stuff like command the spacecraft to take a picture of whatever you want. And the thing that I am most excited about is that Chris told me that they would plan to use the spacecraft to take regular photos of Jupiter and Saturn. And already amateur astronomers are making really important contributions to the study of the ongoing storm activity on both of those planets. And you can take a really pretty awesome picture of Jupiter with an 8-inch telescope. So they are really going to contribute
with no atmosphere.
With no atmosphere, it's going to be even more awesome. So I'm really excited about that, actually.
Yeah.
So
I wouldn't
like
be. I mean, this is great. I think there's huge demand for these kinds of space telescopes. Not even just for hunting for asteroids, but even for scientific purposes. And if they can really bring that price down to, I know the goal is to bring the price even down more to make this much more of a commodity that small universities can get their own space telescope. That there's a lot of reasons why there's always a shortage of space telescopes, and if you can get some more of these up there, I think this is going to be a real boon.
If they can build and validate these spacecraft, 4 of them for $4 million, I don't see why they couldn't launch 20 for $2 million a piece.
And have customers lining up. I think it's fantastic. Yeah, no, I'm really excited. And the way they've launched the Kickstarter has been fantastic. The people on board, the way they put their company together. I mean, it all just makes sense, and you feel like it will turn into a mining industry.
I feel like, that at an event like Space Fest, you encounter a lot of people who have really fantastic ideas, and you know that the ideas probably, a lot of them can come true in the future. But Chris does a really good job of figuring out what the baby steps are that will lead us to actually getting those ideas accomplished. And not all of the visionaries are really great at doing that. Some of them have these vast ideas of stations floating in space, and yeah, that they'd work, but it will take cajillions of dollars. And here's a project that is going to take several $1,000,000, which is not chump change, but it's achievable, and get something done. So I always like to see that.
Yeah, and when you add this with the stuff that SpaceX is doing, I'm pretty excited. All right, well, let's move on. So, David,
actually, I have a
moment.
There's a question coming through on. Let's see, two questions. One's for Emily. Has there been a glacier past? Has there been in the past on Mars glacier movements that could round the rock? So instead of water flowing, could it have been glacial activity?
That's a good question, and yes, there definitely has been glacial activity on Mars. Probably not so much at this equatorial location, but when you look at there's several things besides the shapes of the rocks. First of all, there's just a lot of them, and they're relatively round. There's also features like what they call imbrication, where you've got flat tabular rocks that are stacked against each other. That's what you get in a flowing stream. So there's various other features. Another thing that tells you that it's probably fluvial in this case is the sorting of the pebbles. So generally speaking, when you have a water process, the water moves at a certain speed. It can move only things of a certain size and smaller, and as a river like flattens out, it can keep carrying the smaller stuff, but it can't keep carrying the big stuff. So in any kind of deposit that has to do with a river, you wind up with sorting of the sediment, where you get bigger chunks closer to the source and all the way down to fine sediment at the middle of a lake. And here the paper, Becky's paper, showed that there is in fact a grain size distribution that indicates that this stuff was sorted. You really don't get sorting like that in glacial deposits or in landslide deposits. So that's one of the big clues that this is a fluvial deposit.
And you had another question, Matthew?
Yeah, this one is addressed to me. A question about whether there's a cloud of gas that is currently heading towards the galactic center, and asking whether that sort of black hole munching could explain at least some of the gamma ray signal. And as far as we know, the answer is no. It would not. When you're talking about the annihilation of particles, the signal is going to be like a single color. It's gamma rays, but the principle's still the same. It's not going to be. It's going to be a single. It's going to produce like a single color of gamma rays, whereas the black hole chomping on gas would not produce that kind of signal. So even if we didn't see the cloud of gas until it got eaten, it wouldn't you wouldn't confuse it for this kind of thing.
All right, we've got a few minutes left. I know we've got a couple more stories that I wanted to get to before we wrap this up. One, David, there's an upcoming launch to the Chinese space station.
Yes, there is. In the next week or so, once we're going to be flipping over to June tomorrow, and probably the big ticket launch you're going to start hearing about is the Shenzhou 10 launch, the next manned crewed launch going up to the Tiangong 1 station. This will be the second time they've sent a crew up there. We're hearing right now, originally it was June 7th. I think it's closer to June 10th maybe is when they're going to be doing the launch. The Long March rocket has been rolled out to the facility. They just haven't rolled it out to the pad. And I think it's interesting that when they do these crewed launches, that they actually, the last one they did, they had really unprecedented openness for the Chinese space program. Usually we're kind of left in the dark as far as did they launch, did they not launch, until NORAD starts tracking it. But the last time they did a crewed launch, they had the whole thing live. They had the re-entry, the landing live. They had a lot of stuff and updates coming out on. I watch on CCTV on Chinese television. A lot of times they're doing updates, but that's rare for their space program. Usually their space program for their uncrewed launches are kind of like back in the Cold War days, where we kind of guessed until a few days later. It's like, okay, they did launch something, you know.
Yeah, I mean, all this talk of what's going on with planetary resources and SpaceX and so on, don't forget that the Chinese are going at full tilt to launching their own space station and, and have plans to send people to the moon at some point. So,
It's it's kind of cool to have two stations up there that are crewed right now too. That's kind of like the old what we envisioned in 2001: A Space Odyssey, where there's just like space hotels, and well, we don't have those yet, but
we have one, right? We have one an empty prototype space hotel.
There's the Bigelow Aerospace
Bigelow,
is talking about they're going to be putting a module on the ISS, I think, in 2014, 2015 to test. They're going to put one of their inflatable modules too. So you never know.
Until we get a great big rotating one. What is it? An O'Neill ring, I think it's called.
Yeah, from back in 2001.
Ian O'Neill.
Rotate it for gravity.
Yeah. Cool. All right. And now, Ian, you talked about pulsars being used as a galactic GPS this week.
Yeah, this can be fairly quick actually, but it's kind of a cool story. It actually came out in Technology Review a week before last, I think, and it's based on a paper from the Archive preprint service. But it's quite a cool concept, and it has been thought of before, but it's kind of revisited in this paper. Basically, the big issue when navigating through space, a spacecraft needs to have constant connection with Earth, so ground controllers can work out its location in space. So we can accurately determine by analyzing radio waves, say with the Voyager 1 spacecraft as it goes further and further out to the outermost reaches of the solar system. As it does that, we know how far away it is by analyzing the radio waves that we transmit and receive. That's a no-brainer. But the radio antennas we use, they've only got a certain angular resolution. So even though they're looking in one direction, there's a level of uncertainty as to where it could be within that cone of communication. So as a rule, the uncertainty in the location of the spacecraft grows with distance away from the Earth, as you'd expect. So every one astronomical unit, that's the distance between the Earth and the Sun, every one astronomical unit, the uncertainty grows by 4 kilometers. Now, that's not really a problem if you're talking about satellites in orbit, or you're talking about going to the moon, or even nearby planets, because you don't need that degree of certainty. But when you're talking about a Voyager 1 spacecraft, you're talking about a degree of uncertainty of 500 kilometers. So we don't know where it is within this 500 kilometer disk in the sky. Now, the way you can solve this is by making spacecraft smart. They can actually work out their own location in space. But how do you do that? I mean, you don't have any rest stops. You don't have any signposts as to where they are. So they're just in space. I mean, they've got stars they can look at, and there's guidance stars that they can use to orientate themselves properly. But how do you accurately define where a spacecraft is in three-dimensional space? Now, quite a nifty little thing has come out of the analysis of pulsars. Basically, some pulsars emit X-rays. The traditional way of finding pulsars is using radio antenna, and by their design, radio antenna are very, very big. They have a large collecting area. So to put a radio antenna onto a spacecraft to look for these pulsars is very, it's just not practical. But if you look for X-ray pulsars, X-ray detectors are by their nature very small, and they're shrinking very, very quickly. So these scientists have come forward and they said, well, in the near future, we could possibly put X-ray detectors on these spacecraft to look for the signals from pulsars. Pulsars are rapidly spinning neutron stars that send out a very definite, predictable signal. And so if they can analyze a signal from just 3 pulsars, and we know of about 2,000 X-ray emitting pulsars in our galaxy, perhaps we can actually have a system that can define a spacecraft's location in three-dimensional space down to an accuracy of a couple of kilometers. Now, this could be really exciting, especially when we're talking about asteroid mining, say. Say if you're out in the asteroid belt, it would be very useful for a spaceship to know exactly where it is in three-dimensional space. Otherwise, 100 miles out could be a matter of life and death, or a loss of fuel. So it's just kind of a cool story that, the more pulsars we discover, especially X-ray pulsars, they could actually create a global positioning satellite system, but actually this is a galactic positioning system or a pulsar positioning system. So this could change the way we navigate around the solar system in the future.
That is awesome. I'm sort of imagining, so like, because the pulsars are sending out these regular pulses at like super predictable rates, and so are you measuring your like speed towards or away from the pulsars and the Doppler shift, and that's what's sort of giving you that change in the timing between the different pulsars that you can calculate that? Is that what's going on?
Pretty much, yeah. And
Yeah,
really
okay.
the ingenious thing behind this is going to be the software behind the onboard computer that's going to be calculating all this. But it's pretty much using pulsars in exactly the same way as onboard computers on your iPhone calculates the distance from GPS satellites on Earth. I mean, obviously we've got a network going overhead of GPS satellites. But with pulsars, they're always going to be there, and they're shining at a pretty much predictable rate, pulsing at a predictable rate, and they can use that signal, as you say, to work out exactly how far away, whether you're going towards or away from these pulsars. And by just using 3 of these pulsars, they can define the exact location of the spacecraft. So I assume as the technology advances and matures, it would use more and more pulsars to analyze its position in space. And so the accuracy of knowing the location of a spacecraft in 3-dimensional space could be extremely accurate, perhaps even down to less than a kilometer, even meters, who knows. But
right, and you can imagine this
cool.
becomes like, again, a sort of once this problem's been solved, it's a box, includes the pulsar information, you attach it to any spacecraft that's going to need a navigation system, and now it knows exactly where it is anywhere in the Milky Way, pretty much.
Exactly.
Yeah,
and we're getting better at discovering these pulsars as well in our galaxy, and it's growing very quickly. So there's going to be a lot of options for this future system to use as beacons.
That's fantastic. Could we even use it on our GPS as we walk around?
Yeah, there is that idea as well. You can actually use it down here on Earth, but I think that there's a difference.
The X-rays don't go through the atmosphere, I don't think.
That's the main issue, so you'd have to look at some other wavelengths, but that is a possibility as well. Yeah.
And you could sort of always know that you're being pelted by, say, gamma radiation,
Which is fine. Doesn't do anybody any harm.
Okay, great. Well, I think we should wrap this up now. So let's now I wanted to sort of get a bit of an update, and people can find out more about everyone. So, Sandy, how can people watch what's about to happen, all this research you guys are doing, and where can they find out more about you?
So we will be posting images of asteroid QE2 starting on June 6th here at Arecibo Observatory. Right now, the JPL news office, jpl.nasa.gov, has some fantastic images of QE2, and hopefully if all of our hardware stays together, we'll be getting some even better ones next week. You can find me on Twitter. I'm at Sondy, S-O-N-D-Y, Sandy if I'm at the beach. And I even have a blog. It hasn't necessarily gotten much science on it lately. And before I head out, you can see one last view of the telescope in the window. Nicole's looking really excited. And in addition to asteroids here, we also do pulsar detections as well. So
Fantastic.
This is a multi-use telescope.
David, where can we find out more?
I am at AstroGuys with a Z on Twitter, on my blog, and on YouTube. I am a regular contributor to Universe Today, Listosaur, Canada.com, and I am out under the sky nearly every clear night that I can be. And I'll probably be photographing the sun here in a moment.
And maybe we'll see you on Sunday night.
I should be. We'll see.
Yeah? All right.
I hope so.
Emily Lakdawalla, where do we find out more?
You can find me on planetary.org/blog, also podcasting weekly on Planetary Radio at planetary.org/radio, and on Twitter all the time at elakdawalla, if you can spell it. Otherwise, just look for a retweet.
Right, okay. Dr. Ian O'Neill.
Yeah, you can find me at discoverynews.com under space. I'm regularly writing on there, and also on Twitter at AstroEngine. That's probably the best place to find me. And also my own personal website, astroengine.com.
Fantastic. Dr. Francis.
You can find most of what I do at bowlerhatscience.org, on Twitter at Dr. M.R. Francis. I also cover physics and astronomy for XX Science. You can find me at Ars Technica, occasionally at other places, but I won't list them all. And my personal blog is Galileo's Pendulum.
Fantastic, and I guess I'll have to say something for Nicole. Supposed to be working. Nicole, she is the @Noisy Astronomer on Twitter, and she works with CosmoQuest. So, and of course, I'm the publisher of Universe Today. You can read. Because I don't write much at Universe Today anymore. I'm too busy publishing. But I actually have been doing a series of interesting videos on YouTube about various space questions. So if you want to check that out, just go to the Universe Today on YouTube, and I think you'll find them pretty funny. Cool. Okay, well, so the next big thing I think we're going to be doing here on the network is the Virtual Star Party on Sunday night, which is where we hook up a bunch of telescopes into a live Google Plus Hangout and show you the night sky, whatever's up. Hopefully David will be back and others, so it's really a good time every week.
Nicole would like me to plug the 24-hour Hangout-a-thon, which I believe is on June 15th. Fraser, do you have more details on that?
I don't, except that we will be watching Nicole go crazy on air for 24 hours. But no, the goal here is to raise money for all of the work that Cosmic Quest is doing because of all of the, the budgetary cutbacks that have been happening in science because of the sequester. So trying to sort of keep all of the science outreach and education going on. And so some of the ideas that we are doing include things like this 24-hour Cosmic Quest hangout. So there's going to be a whole bunch of our, all our various space buddies are going to be showing up, and Nicole and Pamela and me is going to be showing up, and I'm not sure who else we've got lined up yet, but we'll probably be hooking up some telescopes. So it's going to be, 24 hours. Not for me, for Nicole. Nicole will do 24 hours. But I'll be showing up. Yeah, so that's going to be happening on June 15th, 16th, so just in a couple of weeks. Cool. Okay, well, thanks everyone for watching, and thanks everyone for joining us this week. That was fantastic, and sorry for the technical difficulties at the beginning. We will hopefully have this not be a problem next week, so we'll see you all later. Thanks a lot. Moving the camera around. Oh, I mean, you can imagine what she's saying. She doesn't even need to talk. We can just see her gestures and her laughter. It's perfect. So play this out for us. What's going to happen over the next few days? Because we're still not at the closest point, right?
I think the closest point is happening this weekend. It's going to start moving a little further away, but this thing is so large and so close that Arecibo is going to get a lot of very good signal to noise on it. We're going to see really exciting details. So you can start seeing in this animation, you can see craters, you can see features, you can see boulders, and when the asteroid comes to Arecibo and we have a much more powerful transmitter here, we'll be able to see the craters in greater detail. We probably won't be able to get too many details on the moon, but we're going to be seeing a lot more about this asteroid. And with the moon, if you remember Kepler's laws of motion, if you know the orbit of something around an asteroid, you can actually figure out the mass of the asteroid from the orbit of the moon. So this moon is really exciting. It lets us do a lot of really cool science here.
Sandy, have they published an orbital period for that yet, that moon?
I bet the Goldstone telescope can point. It can point up, it can point to the sides. They've been looking very low in the sky as this asteroid rises. Whereas Arecibo, we have this giant fixed dish in the backyard. It's 1,000 feet across, but it can't move. So we can only look 20 degrees up from the zenith, from the top of the sky. So we'll be looking at it next week when this asteroid gets higher. And as much fun as it would be to be like Jodie Foster with a giant set of headphones listening to the sounds of the universe, our radio waves are actually converted into signals and fiber optics pretty quickly, and then they come down into our control room where we sling around a bunch of BNC cables, and eventually they come out into a computer that's from the mid-90s. And then we get
destroying the illusion for me.
That's how science gets done, and then eventually this all turns into lovely images like the ones you've seen. I think Emily actually has an animation queued up on her screen right now of asteroid QE2 and its moon rotating. I don't know how we move over to that, but...
Oh, well, Nicole, I'm sure, will be doing it. Yeah.
Yes, Nicole is on it. She gave me the thumbs up.
Yeah, now, because she doesn't have to talk, she can just focus on... Right, right, exactly, yeah.
I'll be glad to do the dramatic reading.
There we go.
So this week we got a ton of space news, so we're going to probably go at light speed. So we're going to be talking about this cool new pass from an asteroid. We've got more updates on Curiosity and Opportunity, the Kickstarter campaign for the Arcid Space Telescope, the end of dark matter annihilation, maybe. How you're going to be able to see the International Space Station at night, upcoming mission to launch to the Chinese space station, rats on Mars, or not, using pulsars as galactic GPS. So, wow, what do I want to start? I want to start with the asteroid first, because that is really super exciting. So, Sandy, if people remember last week, you actually predicted that that not only would have this asteroid pass by, but that it might even have a moon. And How did you know this?
Well, I had about a 15% chance of it having a moon. About 15% of the asteroids that come by the sun that are near-Earth asteroids actually have moons. And about 20% of the asteroids that come by Earth are actually contact binaries, so they look like two potatoes stuck together, perhaps like that. So, you know, there was some chance that this would have a moon, and it was large enough, and by golly, it has a moon. And it's interesting that in the radar images, everyone's saying, gosh, that moon looks so much brighter than it does, but it also looks a lot smaller. But people are saying that this moon is about the quarter the size of the asteroid. And actually, that's just an artifact of how radar images work, that it just looks brighter. It's actually not like a 3D, it's not an image like you take with your camera. It has to do with how far away the object is and how fast it's moving. And since the moon is moving very slow, it appears very bright.
So why don't we ask that question again? And this time you can explain how you went outside with your headphones, plugged into the Arecibo Observatory, and just listened to the sound of the asteroid, and you could hear a moon in there.
Well,
No?
we haven't yet observed it here at Arecibo. It's on our schedule for next week. So right now, our friends at Goldstone, run by JPL out in California, have been looking at it.
Well, hi, everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 31st, 2013. So joining me this week, we've got Sandy Springman from Puerto Rico, who we will always ask her to point out the window so we can see the Arecibo Observatory. Check it out. That's awesome. We've got David Dickinson from Florida.
Hey.
How's it going? We got Emily Lochtawalla from the Planetary Society. Yay! Emily's back. Dr. Ian O'Neill from Discovery Space. And we've got Dr. Matthew Francis. And our silent partner is Dr. Nicole Gallucci, who is with us in spirit, but not here in audio. So there she is. You can't hide behind the Weekly Space Hangout. You just have to, from here on out, your part of this episode will just be hand gestures.
Actually, what I think she should chat everything, and then one of us should speak for her so that it